Hi, in this tutorial I am going to introduce the new tree triangulator. It is basically a two-dimensional measure. I created the geometry already. It is a NACA 0012 airfoil over here, and this is the fluid domain. So you can go to tools, airfoil generator, create the airfoil, and then in another video I show how to create the domain. So under CFD I will pick up this tree set measure, and then a dock widget will pop up. So I will left click on this geometry and then right click on geometry and import. So I can then disable the geometry and then collapse this. So I will go over the settings one by one. First of all, I have here body of influences. So if you're gonna use geometries for meshing, in which you pick up a face or something like that, and then you can basically let me show you that. Now let us create a face over here, and let's say I want to refine over here. So this rectangle face, I will select this, right click and load selected from viewer, so I can hide this again, hide the grid, and this is the body of influence. So I can toggle it, so show or not show. And in the mesh settings, when I click over here, left click, you have settings for min size and max size. Let us crank this up and create the first mesh. So if I hit on this run, it will be quick to create a geometry that needs a higher resolution around the airfoil. So I will in fact create a much higher value for this, and then I will show you how to use other settings to make it finer around the airfoil. So the size factor I will skip. You can basically, if you want to make the whole mesh finer, you can play around with the size factor if you like the settings, but want to make it half the size, for example. The size gradation will tell the mesher how to go from smaller cells to larger cells, so you can also play around with this value. And if I right click on mesh, you can select various options like point, edge, face, and solid. And let me select the edge sizing, and let me toggle the edge selection so I can grab the two edges from the airfoil, and then I will basically hit this one for adding the plus sign, and then if you want to highlight, just click on the H, and the target size, the airfoil length from leading edge to trailing edge is 1000, so let us select a value of 1, and then the core size will be like 200, and the influence distance will be like 1000. And if you click on the Z button, it will create a highlight. So the target size 1 will be at the core distance, so the orange highlight section, and the influence distance will tell how to merge with the background mesh. So if I just create the mesh, I don't know if I selected a really fine setting right now. Okay, so this would be the domain. If I zoom in, that is a very fine mesh over here, and then if I highlight again, you see it will grade with a grading factor of 1.2. It will merge with the background mesh. So what we can also do is, as I told you before, click face selection and hit on the body of influence face and then hit this plus sign, and then let us select the target size of 100. Core distance will be 100 and influence, I don't know, like 1000. And if I hit the Z, you see around the orange section it will be like 100, and then it will grade in the blue section. And if I show the body of influence, it is actually smaller because I selected a core distance that will extend the domain from here to the orange section. And let me choose a value of 5 over here, so just for demonstration, so it will mesh faster. So actually it did mesh faster, and you see around the body of influence section you have finer grid right now. So what is missing is we want a boundary layer around the airfoil, obviously. So let me enable the smoother. The smoother will basically smooth the cells, and then it will look better. And hereafter I will show what cell topology means. So let us enable boundary layers, and then we right click and we add boundary layer, and we have still edge selection enabled. So I will click on both and then hit the plus sign. I can highlight like before, and then I can select the first layer height. Now my cells around the airfoil is like 5, and let me select like 0.5 with number of layers and the growth rate 1.2. And down here in the table you see the thickness of the layers and the total thickness up to this layer. So if I extend, you see the table will also extend. So let me first do 5 layers and show you what the mesh will look like. So over here you see in the trailing edge, well, let us investigate the front section first. It looks really good, and then in the trailing edge you have this extension over here. So what we can do is go to boundary layers, and then we will enable this fan setting, so it will fan out the section over here and will create a better mesh over here. So it would be nice when we would get a fine layer over here. So if I go to boundary layer, the first mesh, the first boundary layer, I will get like 1 millimeters, because the domain is like the airfoil length of 1000. I will scale it later when I export, so this 0.001 will turn into 1 micron. Now when I hit mesh, you will see it will create this mesh over here, which means I can crank up the number of layers to like 30. Beware of the final size and the thickness of the mesh. So this looks like a better mesh. It would be nicer if I would change the edge sizing to value like 2. Now this might take a while, but the mesh over here will look very nice. So Now the rendering. Okay, so what I did right now is I created a boundary layer around the airfoil with a good grading to the section over here, and we have grading over here, and then maybe the free stream domain is too large right now. Let us select the max size of 1000. So that looks better, and you can even go down. I will not do that right now because it would take a little while to create a fine mesh. Maybe let us try 500 and then move on to the next setting. Okay, now I will work with this mesh. So what we can do is we can export this mesh, and before exporting, this is the export button. What you should do is save the project. So I prepared the directory for this. So if I hit this, you will see it will save the project. Okay, what this means now is I can close this, and then if I want to load this again, I will drag the JSON file right into the section, and it will load the whole project back. So the next thing I want to show is the cell topology, what this means. So if I click on this, it will enable. So you have two settings here, quad dominant and polyhedra. If I hit on the polyhedra, it will create a polyhedral mesh from the triangular mesh. So after rendering, you will see the boundary layers are still respected. So thin boundary layers, and overall we have a polyhedral mesh. And if I go to the quad dominant, which I implemented, but I don't really like that, and you will see why. It creates these quads from the triangular mesh, but you see that the alignment is not good. I don't like it. So one can stick to the polyhedra, and then I think that will do a good job. So perfect. So if I go to mesh, you see the thickness of this is like 1 unit depth. I want to make that 1000 because the airfoil length is 1000. And after applying, you see that the mesh will be updated, so the mesh will be extruded, and you have a good good mesh overall. So the next thing is patches. For the simulation we need patches, so I will box select this too, and then hit this add button. The patch type is wall, so right click, rename to airfoil, and then these edges around it, right click, add, and let's call it patch free stream. So if you like the mesh, you can, of course, don't forget to save it. Once you load the project, you can also hit this fast save button, so it will automatically save again right here with updated settings. So let us create a Nakano 0 OpenFOAM, and I will export the mesh. I will scale from whatever unit you have, and then along the way I will renumber the mesh, and then go to the newly created OpenFOAM directory, and it will write the mesh to the directory over here. What you can also do is you can hit this VTK button, and it will then send the mesh to the mesh view over here. If you click on this is like ParaView, and if you go to mesh quality and extend the window, you have mesh metrics over here that needs to be computed. If you hit compute all, it will calculate the mesh metrics which are important for OpenFOAM, so you can investigate the mesh before you export the mesh. And now once you did that, you can change the filter to more orthogonal quality, for example, and then you can zoom in, zoom out, check the mesh. Now maximum value of 70 is good, and after investigation what we can do is create the foam file. Well, let me make a pause here. I will show in another tutorial how to use the case builder. So I just wanted to create the control dict file. Let me just quickly do that so I can run check mesh. So connect to the Windows subsystem for Linux, and then once loaded I will call check mesh. So as you can see, it says failed one mesh check, and this is the high aspect ratio which we want, because the boundary layer has a high aspect ratio, but the maximum value we have is around 1227, which you can also see here. If I switch over to aspect ratio, hit apply, it will load the calculated aspect ratio, and you can investigate where it is, and it is basically in the bound. It needs to be around the boundary layer somewhere. It might be very tiny. Yeah, right at the airfoil, as you can see here. But that's okay, that's what we want basically to resolve the boundary layer. Okay, so and then you can also see that the patches are correctly exported. You can also investigate the patches over here, like we have airfoil and free stream. Let us do this back like this, and then at the back and the front. So I think I covered everything that I want to cover, so don't forget to save your project, and don't forget to when exporting the mesh to rescale. So let me show you one more thing. As for sizing, we said we want to target size of 2, and let us verify that. If you go to the selection tab and select the edge, it will create the edge selector, and let me zoom in. Well, this is not a triangular mesh, so the target size would be a little bit different than that. But if you hover over it and then click, the highlight will disappear, and you see in the left bottom corner the edge length. Okay, so if I zoom into the boundary layer and I hit on that, you see that is 0.001, and this is what we defined in the first boundary layer height. So I think that's it for now. So thanks for watching, and it would be cool if you would use this tool and then provide feedback. I think this is a very handy tool for airfoils and maybe also for other type of simulations. So thank you.